Hi, I am Dr. Eli Kolberg from Unlimited Robotics. In this video, I will talk about a diode, part 6. The prominent characteristics of a diode is that it conducts current in one direction only. However, unlike a resistor, a diode does not behave linearly with respect to the applied voltage. Instead, it has an exponential current voltage, or IV, relationship, and therefore we cannot describe its operation by simply using an equation such as Ohm's law. When a suitable positive voltage, also called forward bias, is applied between the two ends of the p-n junction, it can supply free electrons and holes with the extra energy that required to cross the junction, and the width of the depletion layer around the p-n junction is decreased. Negative voltage, which is called reverse bias, that is applied to the diode will cause the free charges to move away from the junction and by that increase the depletion layer width. Next figure presents IV graph of a diode. In the right part of the graph, there's the forward bias area. We see that up to about 0.7 volts, the current is very low. After that, there's a knee. We see that the current increases exponentially. In the reverse bias area, we see that it takes very big voltage in order to what we call to break the breakdown area, and until this voltage, the current is close to zero. Forward bias and reverse bias have an effect of decreasing or increasing the active resistance of the junction by allowing or blocking the current flow through the diode. In other words, the depletion layer widens with the increase in the application of a reverse voltage and narrows with the increase in the application of a forward voltage. This is due to the differences in the electrical properties on the two sides of the p-n junction, resulting in physical changes taking place. One of the results produces rectification as seen in the p-n junction diode static IV characteristics. Rectification is shown by an asymmetrical current flow when the polarity of the bias voltage is altered. Diode symbol is shown below. It looks like an arrow with a vertical bar. The conventional current flow is from the plus to the minus, and it's the direction of the arrow. The opposite direction has a block. It's like a wall. It's a block for blocking the current. Before we can use the p-n junction as a practical device or as a rectifying diode, we need to firstly bias the junction, meaning connecting a voltage potential across it. On the voltage axis in the previous graph, reverse bias refers to an external voltage potential which increases the potential barrier. An external voltage which decreases the potential barrier is said to act in the forward bias direction. There are two operating regions and three possible biasing conditions for the standard junction diode, and these are 1. Zero bias, meaning no external voltage potential is applied to the p-n junction diode. Reverse bias, the voltage potential is connected negative minus V to the p-type material and positive plus V to the n-type material across the diode, which has the effect of increasing the p-n junction width. Forward bias, meaning the voltage potential is connected positive plus V to the p-type material and negative minus V to the n-type material across the diode, which has the effect of decreasing the p-n junction width. Forward bias, meaning that it allows the current to flow through the diode, and reverse bias, meaning that it blocks the current flow through the diode. That's it for now. Thank you for being with me. Hope to see you next time. Bye bye.